Everyone knows that a giant rock from outer space hit our planet millions of years ago.
This catastrophic event wiped out the dinosaurs and changed the course of history forever.
But now, with advanced technology, researchers have put together a highly detailed new timeline.
This timeline shows what really happened during those fateful hours of destruction.
And not only this, scientists think they finally know where the giant asteroid came from. This discovery raises an urgent question. Is Earth currently the target for another huge space rock? Would we be able to survive if another massive asteroid was heading directly toward us? You will be surprised and probably shocked at what NASA astronomers recently discovered in space. So now, get ready to experience the disaster that almost wiped out life completely on Earth. Let us travel back in time to witness the ultimate cosmic collision in vivid detail.
The giant asteroid's impact into the shallow waters of the Gulf of Mexico was bad enough. But then, an unimaginable amalgam of additional global disasters immediately ensued across the planet.
Fiery rocks fell from the sky, igniting massive wildfires that consumed entire prehistoric forests. At the same time, colossal tsunamis inundated distant shorelines, sweeping away everything in their path. Researchers found that the very first day of the Cenozoic era was peppered with cataclysms. They released a new record of this day of chaos in the prestigious scientific proceedings. Their detailed timeline was developed using high-resolution photography and advanced microscopy techniques. They also utilized computer tomography imaging and precise magnetic measurements of sedimentary rock.
This rock was recently recovered from Chicxulub, one of the largest impact craters on Earth.
And it all began with a quiet night sky, millions of years before humans existed. Imagine you were somewhere in North America, about 65 million years ago. During this ancient era, magnificent dinosaurs ruled the land, unaware of their impending doom. If you were looking up at the night sky, everything would seem perfectly peaceful. You would have probably seen what appeared to be a bright star shining in the distance. But if you watched this peculiar light for an hour or two, it would grow. The object would seem to grow in brightness, but it would barely move at all. What you would be looking at is not a star, but a colossal asteroid. This massive space rock was somewhere between 11 to 80 kilometers wide. It was on a direct intercept course with Earth, traveling at incredible speeds. The asteroid was hurtling toward our planet at 72,000 kilometers per hour. Hours later, the asteroid plows through Earth's atmosphere, heading straight for the Yucatan Peninsula. At speeds that high, Earth's atmosphere actually acts like a solid wall of water. Smaller space rocks, called meteors, hit the atmosphere like pebbles thrown into a pond.
They decelerate rapidly at high altitudes, burning away from the intense friction.
While some bigger pieces of rock survive the journey and fall directly to the Earth. But the mountain-sized Chicxulub asteroid hits our atmosphere like throwing a boulder into a puddle. It maintained its velocity and plunged through the entire 6 miles of atmosphere in seconds.
The asteroid shrieks over Central America, emitting the mother of all sonic booms.
These deafening shockwaves would shatter eardrums across all the continents of the world.
The dinosaurs were likely terrified, running in all directions to escape the noise. They had absolutely no idea what was just about to happen to their world. In fact, except for sea turtles and crocodiles, no large four-legged animal would survive.
The mountain-sized space rock falls so quickly that the air itself cannot escape.
Under intense compression, the air heats to thousands of degrees almost instantly. Before the asteroid even hits, compressed superheated air vaporizes much of the shallow sea. This shallow sea covered the Yucatan Peninsula, which was soon to be obliterated. Milliseconds later, the rock plunges through what is left and slams into bedrock.
In that single moment, a catastrophic chain reaction of events occurs across the globe.
The impacting asteroid exerts so much pressure on the Earth that soil flows like fluid.
The flowing up and down movement of the Earth is like a double splash.
It resembles someone doing a massive cannonball into a giant swimming pool. The initial splash in all directions is followed by a delayed vertical splash. This happens when the cavity created by the asteroid rebounds violently to the surface.
The first wall of Earth gouged outward at impact is 32 kilometers high.
The impact hole nearly breaches Earth's mantle, exposing the deep layers of our planet. And when the cavity rebounds, the Earth rises at over 1,600 kilometers per hour.
It reaches heights taller than Mount Everest, creating a temporary mountain of debris. Within minutes, this mountain of debris almost entirely collapses in a series of secondary explosions,
leaving behind a smaller mound called a crater's peak ring in the center. At the same moment, the asteroid applies its immense pressure to the bedrock.
It converts the kinetic energy of a 7.5 billion-ton rock. Traveling at 16 kilometers per second, it turns into searing heat instantly. The Chicxulub impactor delivers approximately 1 septillion kilojoules of destructive energy.
This is more energy than 1 billion Hiroshima atomic bombs combined.
The kinetic energy transferred by the asteroid excites molecules to extreme temperatures. These temperatures are far hotter than the surface of our sun. The heat rips electrons from atoms, ionizing the air into plasma.
An expanding fireball of plasma exceeds 10,000 degrees in the atmosphere.
It is turbocharged with vaporized rock blasted out at hypersonic speeds.
The heated, rapidly expanding air forms a massive blast wave of pressure.
This blast wave expands outward at more than 1,600 kilometers per hour.
If this asteroid hit the same spot today, it would vaporize Texas.
It would deafen you in New York and blow out windows in Buenos Aires.
The Chicxulub impactor rings the Earth like a giant bell in space. Waves in Earth's crust radiate away from the impact zone at high speeds. These seismic waves then trigger massive earthquakes across all the continents. If you were on the other side of the world, you would feel it. You would feel the ground shaking 30 minutes after the initial impact.
The impact triggers colossal tsunamis as high as modern skyscrapers. The first of these massive waves hit Gulf coastlines within the hour. Waves ranging from 600 to 1,000 feet tall smash into land.
They flood tens of miles inland, destroying everything in their path. The waves temporarily reverse the flow of rivers, rushing up riverbeds. Tsunamis smash into the eastern coast of the United States hours later.
They max out at 600-foot-high walls of water.
These walls of water then slam into Europe, Africa, and Mediterranean coasts.
Within 15 hours, waves arrive on every single coastline on the planet. The ocean sweeps away everything in its path and sucks it back to sea.
It already sounds like Armageddon, but even more disasters are coming.
The Big Rock Splash launches 25.5 trillion tons of Earth into space. Some debris travels at speeds exceeding Earth's escape velocity into orbit.
These rocks orbit the sun, and some probably reach the moon.
But the majority of ejected debris returned back to Earth within the hour. These glass-like chunks, called tektites, pelted the Earth in lethal quantities. Regardless of where dinosaurs were, they were hit with this fiery hail.
But these glass bullets did not need to hit them to be fatal.
These glass-like chunks, called tektites, pelted the Earth in lethal quantities.
This radiation set fires across the planet, turning Earth into an oven.
Most of the world's trees burned, leaving only ground-nesting birds to survive. The soot layer blocked 90% of sunlight for 2 to 3 years. This caused a deep global freeze, dropping temperatures by 50 degrees. Today, NASA's DRT mission tests our ability to redirect dangerous asteroids. By colliding a spacecraft with a moonlet, we hope to alter its orbit.
Only time will tell if we can prevent the next mass extinction event.